I do fast. Yeah. I fast. I actually fast every other day. So
Hello. Oh,
I fast it. Oh, go ahead.
sorry. Yeah. Hello, and welcome to Apropos. We are a closure video show where we talk about closure. We get a guest, and we get to see their setup and ask them all sorts of great questions. And you can watch us on YouTube. Please subscribe if you like it. Before I introduce our guest today on the panel, we have Mia, and I'm Eric, and we might get Ray. We're unknown about that. And our special guest today is Nathan Marz. Hello, Nathan. How are you?
Hey guys, I'm good.
Yeah, so it's kind of early there where you're at.
Yeah. Well, I wake up at 5:30, so I'm already pretty awake.
Okay, nice, nice, nice.
Wait, so
Um,
we're live right now
we're
on.
live. We're going. Yeah.
Oh,
Right now.
do we have any interaction with the audience?
Yeah.
There is a chat, and so the YouTube chat. So if you're listening now, you can drop questions in the chat, and we will try to get to them.
Uh, yeah, and I keep an eye on the chat next to the video.
That's it's like being on a real show. It's exciting.
Yeah, yeah, we're
Yeah.
trying to like a call-in show, but yeah. Um, so cool. Let's go through the questions that we've got. Mia, do you want to get started with that?
Oh, me? I don't
Oh,
have them open.
you
You
don't have
usually
them? Okay, I have
have
them.
them open.
Well, Nathan, would you show us your editor setup?
The editor setup, yes. I mean, it's a little bit embarrassing compared to
Great.
everyone else,
That's
but
wonderful.
We
Th-
want to see
This
the real
this
thing.
this is that kind of show.
Yes.
Oh, anything that you would feel uncomfortable showing to uh
right,
people who we would like for you to reveal to complete strangers.
right. So like, um, you guys can see my screen, right?
Yeah.
Yes.
So they'll just like show something from like the Rama source. But it's like really primitive. Like I just use text edit. So
Wow.
yeah,
Okay.
Oh.
it doesn't have like power edit or none of the fancy features that you guys have with like code coloring. Yeah, I just don't feel like I need that.
And it's got the spell check on, so you're getting squigglies for English words. All
Right?
the stuff that's not English. That's great.
Are you
Not
pulling out
bad.
like
But like if I want to like open up two files, then I can just do it like this. So if I look, I don't know, if I open up this file, and then what I can do is I can just like manually
Oh, that's
do it like
nice.
this. So I can have like a dual, it's kind of like a dual monitor setup. So
Right. Instead of managing tabs or something, you're
yeah. Actually, hold on.
okay.
This is not, I think this is, hold on, let me just, I think it's out of date. Let me update it. Okay, there we
And
go.
you're using SVN.
Yeah. So
Wow. Okay.
I know Git is like the popular thing nowadays, but in the old SVN versus Git wars, Git obviously won that and most people use that, but I'm sticking with SVN all the way. So
Okay, well,
do you really use text edit with the spell check turned on for as your editor?
all right,
I
I'll show my actual editor now. I'll close all this.
okay, all right. No, don't,
he trolled us. Oh no.
there was no way. I was not going to believe it. I do not believe it. I this is the
Yeah, no, I just use honestly my actual editor setup is not much less embarrassing than that, but I actually still use Atom. So, like here's like I just have like Rama open.
Okay,
Um,
Adam.
do
Got
at least
it.
have code coloring. And actually we do have it set up with Zprint, so if I were to go like uh second hold on. Okay, yeah, anyway, we can see it auto format. So like on save it'll auto format it.
Okay.
And so I don't have to like think about that stuff. So still don't have parrot or anything like that, but actually I find with the auto formatting also will error if it can't do it.
Yeah,
there we go.
right.
Yeah.
So that's fine. And actually auto formatting is just really nice because then you just don't even have to think about it anymore.
Mm-hmm.
That's
That's one
pretty,
of the things that I love about Lisp and everything is parenthesized versus a white space language like Python
yeah.
is like you can't really format it automatically because it's white space and it doesn't know where how it's supposed to be indented. But with Lisp, yeah, you could put it in, like you could put everything in like a new line and then it'll put it the right way.
Sent it correctly. Yeah. So that's nice. And then that's pretty much it. I mean, Atom, it's like, I can switch between files very easily. And I have like it set up like Command P is just like, file search, and Command B will be recently used buffers.
Mm-hmm.
That's pretty much it. And then for REPL, I just use like Bruce Howman. He made this thing called REPL readline. So it's like a nicer terminal REPL.
You've
we
got
call it
you've got your editor and your REPL open in separate windows.
Yeah, I don't have them together. So
They're not connected. Okay.
I
So
don't know if you used the text edits internal REPL to
so wait a second. So when you change your code in your editor, how do you get that into your REPL?
I just do a manual, just require reload.
Okay, got it. Got it.
Yeah.
No one's ever pranked us before. That was so funny.
I know. Yeah, you really got us there.
Yeah.
I'm delighted.
I honestly forgot how to use Subversion completely, so I had to use ChatGPT to like tell me how to set it up. Yeah.
I was gonna go deep onto like why you're using Subversion. You must have a really good reason, but okay, you got us. You got us.
Good reason for it. But
When I was pregnant, we told everyone that we were naming the baby Bulldozer, so they'd leave us alone. And people were so polite. Like, oh, is that a family name?
What a unique name.
And I feel like we were like doing that with your SVN text edit setup.
But yeah, anyway, Atom is like obviously Emacs is better, but I do find that most of programming is just not even is you're just sitting there thinking, so it doesn't really matter that much.
Yeah, so I wonder, I mean, I do wonder about that. I do, because so I agree that most of it is thinking, right? But when you're using the REPL, there's a fast loop that you get into of
Mm,
like you think about something and then you have to type it in, run it at the REPL to check it.
mhm,
And so it is on the critical path, like how fast you can type it and run it at the REPL and like, read and understand what gets displayed during that.
mhm,
Um, and so I'm uh, I also feel like, if I learned to type faster, like would I really be a better programmer? I don't think so. If I learned all these millions of keystrokes in Emacs, like would I really program better? I don't think so. But at the same time, when I do the logical analysis, you know, it seems like if there is a threshold where, like, if I did have to go to the terminal and type require da 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 every time I needed to reload my code, I feel like I would be slowing myself down.
yeah.
So
We don't have to type it up every time. Usually I just press like up,
you
enter.
press right. So you type it in.
It takes half a second. So
Yeah.
I guess what I'm curious about, ever since we saw David Nolan's 10 million line org mode file, is most programming is thinking. So how do you organize your thoughts?
Mm.
well, I do that in text files. Um, I can show you an example. Hold on a second. Let me find an example. Hey Ray.
Hey,
Ray, you made it. Yay.
thank you.
Yeah,
Yeah, this
thanks. We got
I
people who
should have
missed it.
sent out a reminder. I should have
it's no
sent out a
problem.
reminder.
No problem. Good
But
to
did
see
you
you
know
again,
that we
Nathan.
got trolled? You'll have to see it on YouTube. We got
Mhm.
trolled. He totally got us.
You'll have to like and subscribe.
Yeah.
Yeah, I will. I'll have to get the notifications. Yeah, that's for sure.
Yeah, it was totally like it was better than getting Rick rolled. We were totally he showed us his editor setup and it was text edit with Subversion. Um yeah.
That's news
Anyway.
to me then. Okay, because I happen to know it's Atom, but
Right, right. That's what he's showing us the real thing now.
There we go. You would have, it's a good thing you weren't here. Would have ruined the joke.
Yeah. But yeah, I basically have like text files. I used to, so when I started working on Rama, I had one text file. I was telling Ray about this on his other podcast. But the original name for Rama was my working name actually for a few years. I called it Supernova. And I just had a file supernova.txt and it ended up being like unbelievably long. It was just a stream of consciousness for like years. Now I'll make a new text file for each project. But like here's an old one when I was developing Rama's like Java API, and it's just like same thing, like stream of consciousness. I'll just put in like pseudocode here just to like work it out and see how it looks. And then by the end of it, I'll end up with like a to-do list of like things I have to do. What's the plan? What are open questions that I have to like figure out that I haven't figured out yet? And it's not like
Yeah.
very organized. It's org mode is obviously quite a bit more organized than this, but this like works well for me for thinking.
Yeah,
You
so it's
do
just
you
a
know?
TXT file, so you're just
Yeah,
free forming it, like
freeform.
those like bullets and everything are just your
Yeah,
own.
exactly.
Yeah.
Do
Like the
What
these
I
first,
become
wanted to see,
docs?
Nathan, was that board behind you with the bits of red string, you know? Those.
not that fancy. So it's like pretty primitive, but I don't know. Thinking is a pretty primitive thing to do. So this is kind of what works for me.
So do these notes become docs? Uh, or
Oh, no,
do you ever like feed
they're
them
way
into?
they're way too incomprehensible to become docs. Yeah, yeah. No, the doc. I mean, writing docs is a whole other thing that takes a long time. This is more just like most of it is just like I need to see. It's all basically I approach everything as unification of use cases, right?
Mm,
Trying to make something. So like, what are all the use cases I need to support, and what's the simplest set of, or what's the simplest API, the simplest set of abstractions to match all those use cases. And you always have to be in terms of concrete use cases, and that way you don't have to. You'll never over engineer, right?
sure.
Um, that's obviously a very deep topic to talk about, right? But philosophically, that's how I approach everything. And essentially, what these files are my struggle to unify the use cases. And so I'll spit out some code as like a, what if I did it like this? And then I try to work it out. Okay, what if I do this? Let me try to do all the use cases in terms of this idea, and then I see what happens. And then, most of the time it doesn't work out for one reason or another, and then I need to figure out why, right? And a lot of times that means I need to go back and challenge an assumption, and then I'll try again with that assumption changed and using some different approach. And then finally, when it actually works out, I mean, this one was not very challenging doing the Java API, but other ones are a lot more challenging. And then once it works out, then I can figure out, okay, now what's the sequence of steps I should do on the implementation side to make it a reality? And that's where I always end up writing like a plan thing to actually implement it. And then I just go step by step and then kind of eliminate the thinking from the the implementation process.
Well, one thing I didn't ask you actually, Nathan, which might be, I mean, it's a bit of a left field question to some extent, but following on from that was like assuming, because you've made this thing now, which is like 100x, more productive in terms of code than Twitter, and I think you're right. From my understanding and from my reading about things and my understanding of the sort of field, as it were, this does seem like a very concise implementation of a generic idea. So I was just wondering whether some of your thinking tools, the text that you've done, whether you kind of had reflected on that and thought, well, some parts of this thinking like worked well, and it's because of X and Y and Z. And then other parts of this thinking did not work so well. I had a lot of dead ends. I struggled a lot. Can you see any differentiation there in terms of the work that you did or the sort of routes that you followed, or is it still a bit fuzzy?
You mean like have I learned and evolved my approach, you mean? Like
Yeah, yeah.
this? I wouldn't say not in fundamental ways. I think just like fundamentally in terms of build via the unification of concrete use cases, that is the fundamental like I'm absolutely just like religious about it. Like you just
Mm.
always approach it, always think about it that way. I mean, I think probably like I think you become better with experience. Like the more you push yourself and stretch yourself, and God knows I've stretched myself a lot the past like decade. You get better, I think, at seeing things, having a more intuitive understanding of like, oh, that's a bad approach. Don't even bother with that.
Right. Right.
Or you just gain a better appreciation of like principles, right? Like something like I've really come to probably like the number one thing actually that I've learned like since I started working on Rama was the value of composability. Like if you have composability, that's an incredibly powerful thing. That means you instead of having to do things from scratch, you're able to express them by combining simpler primitives together. And what you learn from that. And I think every Lisper has some understanding of this. But basically,
Mm.
what I've come to really appreciate is that composability comes from uniformity. So
Mm.
if you can define things in a uniform way. So like with Clojure or Lisp, it would be the fact that it's homoiconicity. Code is data, and that unlocks an incredible amount of composability in language, right?
Mm.
Like the reason why Clojure macros are so powerful is because you're able to compose the language back on itself. You can't do that in a non-Lisp, right? That's why it's so powerful. And so that is something I'm always looking for, right? It's like, so now I've uh, it's become like second nature to me, right? To like look for uniformity and bias towards uniformity when
Mm.
in the way I explore and think about things. And that's all over Rama. Not just like that's all over just like the actual API of using Rama, but also all over the implementation of Rama as well. So it's like things like that, I think, that I've learned that help me essentially like like essentially experience gives you a pile of heuristics to make you more efficient when you approach a new problem. And that's one of those like big heuristics that I use for
Mm.
in the exploration process.
Do you also think that like uniformity implies some kind of, let's say, the symmetry, the beauty, the delight of this kind of standardization or this ability to normalize things, it feels then more powerful, feels right. It has a sort of, a reinforcing feel
Definitely.
about it.
Oh yeah. It's all that stuff. Elegance,
Mm.
beauty, power. Like just like the feeling of it is like so much like that's what you get with uniformity.
Mm. Mm.
I think it's because of the composable things you're able to do on top of it.
Right, and you're composing things that you've pulled apart, right? So you've looked at the problem of building a modern application,
Correct.
and there's all these parts that are sort of like the de facto way to build it. Like there's databases, there's like web services, microservices, and all these pieces that people nowadays turn to.
Yeah.
Maybe there's like a queuing server or something, like a Kafka or something, and you've just pulled it all apart into like
Right.
smaller pieces that are recomposable.
Yeah. So in terms,
And
so let me give
yeah,
like an example, right? Um, so like, okay. Yeah. So here's like an example, right? So to look at databases, right? Databases have data models, right? Relational, key value, graph, whatever, right? And it has a fixed API for what you can do with that data model, right? And so what I've done with Rama is pulled that apart into the simpler primitive of data structures. A data model is just a particular combination of data structures. And in Rama, instead of dealing with data models, you don't make a key value store in Rama. You don't make a graph store. You don't make a columnar store. You define your storage or P states in terms of data structures. And any data model can be represented as the composition of data structures, right? So the uniformity is it's just data structures, right? And then you just compose them together, and now you're able to do every data model plus infinite more, and that just solves so many problems just all at once.
but
I'm
So
does
like
it
gonna
open up? Oh,
yeah,
sorry, Mia.
I'd like to see an example. I'm having a so are they schemas? Is this are these composable schemas?
Yeah, could you explain this code a little?
yeah,
Yeah.
yeah, yeah. So like this is like we have a open source project called Rama Demo Gallery. It's just a bunch of examples of using Rama like end to end to solve problems, and then every example is like very heavily commented. Every example is in both Clojure and Java. So like this is the Java version. It's doing the exact same thing as the Clojure version, just defined in Java. Well, we'll stick with the Clojure version, unless you guys really want to see the Java version. Um, but like
We'll
this
leave
is
that as an exercise to the viewers.
right.
I don't
Um,
want to Java.
So Rama is a super deep topic, right? So I'll just focus on just the storage part of it for now. But like you create a all right, well, let me just summarize the high level model really quickly, right? So do I have a picture somewhere? Hold on. Where do I have a picture of that? Oh, you know what? Um, right. So this is a good picture of Rama, right? So like traditional application would look like this. You have an application layer doing reads and writes to a database layer, right? And this you could have a million tools underneath this, but that's essentially the architecture, right? This could be like database layer could be like Postgres, your application layer is your web server, right? That'd be like really simple. So the Rama model is based on event sourcing. So all data comes in through a log. Then you have your business logic, which consumes the data from the logs, and then you materialize any number of materialized views of any shapes. And so this whole thing, this is actually down here, this whole thing is called a module, right? The logs are called depots. The code that consumes the log is called topology, and then your materialized views are called p states. And so that's what we're looking at here, right? So this is a time series module. This is doing URL analytics. And this is just this module wants to support queries of the form, get me the number of, what is this actually doing? Hold on a second. Oh, okay, it's not doing page views. This is doing like latencies, but it's the same approach. But this is basically saying, get me like the average latency of page views to this URL over this range of hours, right? Any range of hours that you want to do. And so we have one depot here called render latency depot, and this is going to take in objects, just these objects right here, right? So every new piece of data is a render latency object, which is for a URL, what was the time to render it, and what was the timestamp that the page view happened, right? And then this is going to create a topology. That's going to be where we define the code to actually materialize the p state. And this is the p state it's going to create. And so this p state is called window stats. All p states begin with the double dollar sign. And then you give it basically here you say, what is the shape of the p state, which is what are the data structures? So this is a schema. It's a schema in terms of data structures. But then you use it just like the data structure later on. This is saying it's a map from a URL, it's a string, to a keyword. The keyword is going to be granularity. So this is going to compute, I think it's hour, day, week, and month granularities. Essentially, the reason why it keeps the higher granularities is to speed up queries that are over very large ranges, right? So that you don't have to fetch as much from the storage, right? And then inside of here is going to be another map from a bucket to the stats for that bucket, right? And then we saw the stats before. For every bucket, we just keep track of how many events were recorded in that bucket, what's the total, I guess the sum of the latencies, and what's the min latency we saw in that bucket and the max latency we saw in that bucket, right? The average would just be the total divided by the cardinality, right? And then when you actually use it, you just use it like a data structure. The reason it's called p state means partition state. So this is actually distributed. So basically every partition of this p state is going to be of this form. It's this map of maps, right? This subindexing thing here, all it means is that this map could be very, very large. And that just means that when Rama stores it on disk, it's going to store each value of the map individually, indexed individually, as opposed to serialized and indexed as just a single value, right? So basically, like if it's going to be like have more than a few hundred elements, you should subindex it. But then otherwise, you use it just like a regular data structure. This is the code that actually computes, like does like actually materializes that p state. It's actually really simple. It's only a few lines. But like this is the portion where it actually aggregates. Yeah. We're getting into a lot of stuff here. But this is doing a form of write where it's doing a write in the shape of what we're writing to. So it's saying we're doing aggregation where we are writing a map of URL to granularity to bucket, and then we give it an aggregator for how to update the value at that point. Yeah.
Okay.
Rama is a super deep topic. There's no way I can possibly explain like every detail of this in just a
Well,
few minutes. But yeah, I just want to focus on just like in terms of just focusing on one thing, the composability aspect. It's storage is really simple. It's just data structures, and you interact with it like a data structure. When another way that you could write to this would be And this is actually what this compiles to, but you can just use the base API for dealing with PSH is Spectre, right? Spectre is an abstraction for um, making it really concise and efficient to query and manipulate data structures. And so it follows pretty obviously, it would be a really good abstraction for P states. And so that's typically how you interact with P states. So like this one, we could do like this. Oops. But instead of writing that compound call, I could have done it like this. Like update. Right. In the code, I could have just done this, and then update stat would have been like essentially an anonymous function.
I'm curious about, as we're watching you do this, I'm curious about, it looks like you have naming conventions using symbols to
Yeah. So I kind of just threw you guys into Dataflow like all of a sudden, but like what you're looking at here is a different programming paradigm. This is not normal Clojure. And so yeah, if we had like 3 hours, like I could take you like through all of
Sure,
it.
yeah.
Like high level, it's actually continuation passing style reified into a programming paradigm. This is actually probably what I'm most proud of actually in all of Rama is this Dataflow language. It's general purpose. It's like Turing complete. Anything you do in Clojure, you can do in this. But basically, the like the high level way in which you think about it is that with like Clojure, it's call and return, right? You call a function, it returns one result, right? And it's the very last thing it does. With Dataflow, it's call and emit. And so you call an operation with some arguments, like right here, we call single window stat, which is actually just a regular Clojure function, right? That just creates an object. And you give it an argument, and you can see this corresponds to the fact that this has one argument, right? But instead of returning a value, it emits values. And then what you do is you explicitly bind the emits, right? And so here we bind the emit to the variable single stat. Variables begin with a star. It's a symbol that begins with a star. And so it's Dataflow. And where this is different than like Clojure, but with call and response, is that operations don't have to emit just one time. They can emit multiple times. They can emit 0 times. They can also emit to multiple streams. They can fork. So it's like it's actually a generalization of functions, which is like an unbelievably powerful concept. But in terms of like getting back to my point about composability, so this is one part in which how Rama makes things composable that was not composable before. We break apart data storage into data structures, right? And then this does all the stuff databases do, right? It's durable on disk. It's incrementally replicated. You can satisfy any database use case with this, but now you're able to tune your storage to exactly what's needed for your application. Dataflow, in terms of getting back to uniformity and composition. So this is like, if you've never seen this before, this looks really, really weird, right? And it's like, why would you even bother with this instead of using Clojure? And the reason is because you can do stuff like this. Well, this is, let me actually see an example that's actually using partitioners. Okay, but here's like an example that uses partitioners. I'm not going to explain the whole example, but here I'm coding, right? And when you're coding, you're just on some partition. It's fundamentally a distributed paradigm, right? So when you code with Rama, it's basically going to be scalable by default. And so you have to think distributed. And so when your code is running, it's running on one particular machine, right? And it has access to whatever data is local on that machine, whatever partitions of your P states are like actually exist in that machine. But when coding, like, you start on one machine, but you need to actually update something somewhere else or query something somewhere else. You need to be able to jump around the cluster doing things. And in Rama, you do that with something called a partitioner. And a partitioner actually doesn't look any different than any other code because it fundamentally isn't any different than any other code. So like right here, I could be running on one machine and then I do a partitioner. The naming convention for partitioners is to start with the pipe symbol. And this is say it's going to partition based on the hash of the user ID. And so this code right here and this code right here, they're running on completely different machines. We have completely switched the machine we're running on, but you read the code linearly. There's no callback functions, like the rules of closures and all that stuff still maintained. So any variables that existed here, you just continue using them here. And the Rama compiler sees what variables are used after the partitioner boundary, and it only sends the variables over that are actually used afterwards, right? To minimize the amount of transfer. And so what reifying continuation passing style into a programming paradigm does is it creates a uniformity that's exploited for distributed computation. Something like this, right? I talked about how it's call and emit, right? And so partitioner, it's the same thing. It's call and emit, but it emits asynchronously somewhere else. But fundamentally, it's still call and emit. It's no different than any other operation in Rama. And so that's where the uniformity and composition comes in for data flow.
Right.
Yeah.
That's so when I'm reading this, um, I'm getting this idea that I have to like it's this thing that happens to me when I'm helping people learn Clojure. There's a lot of Clojure skeptics out there, people who like don't like it. And one of their complaints often is that, hey, when I'm doing Java, I have a user class and it has probably 150 methods on it. But like I see these are the operations that are available on the user class. Whereas when they look at Clojure, it's like there's nothing about users anywhere. It's all stuff like here's an atom and I'm going to swap this function into it and so it's very composable. Clojure is very composable. That atom is like a very general purpose concurrency primitive.
Mhm.
But it has nothing to do with users. And so they are just like they feel lost because they're like, where's the user logic? And um, I guess I like Clojure, so like to me it makes a lot of sense. Have you run into that with this where people are like, okay, like yeah, P states they sound like they're great, but like I want to store user information. Where do I do that? Like is it like that kind of have you
Yeah.
noticed that?
Well, I mean, so Rama is you're learning a fundamentally new way of thinking about building applications, like period,
Mm-hmm.
right? In terms of there's so much new stuff in here, right? So absolutely I run into that. And like one of the things um I think Rama has I think I said this on Ray's other podcast, but there's a big unlearning curve to using Rama.
Yeah.
So Rama has a learning curve of learning a lot of new stuff, but there's also an unlearning curve to get your mind out of the ways that you've been taught to build things for the
Mm.
past, or that the
Mm-hmm.
whole industry has been teaching you to build things for the past half a century. So that like the amount of inertia that Rama's fighting against is kind of insane. And so yeah, I absolutely run into that. It is a
Which
challenge.
and that makes me totally believe the 100x thing is just once you can get your mind past all of your habits that you've learned
Yeah,
over however many years you've been in the industry,
correct.
like if you've got better primitives, the same way I feel in Clojure, we've got better primitives than Java. Like obviously we're going to be better,
Yeah,
we're going to
exactly.
be more productive.
Exactly.
Um,
Well, and the 100x thing, it's like it's not even something theoretical. It's empirical, right? Like
uh-huh, uh-huh.
our Twitter consumer product implementation is literally 100x less code than Twitter wrote. Like that's empirical. In terms of understanding the reason why that is, the reason is because we have better primitives, like
Right.
way better primitives. And so we were
They're
all the
built for a distributed world, whereas the databases and the other stuff is kind of built for a single server world.
well,
And
no,
we've just kind of,
there are plenty of
uh,
databases. There are plenty of databases built for a distributed world, but they're based on non-composable primitives. They're very specific, and so
mm,
they create a lot of complexity because of that. The fact that Rama is so like Rama is like two things. Like first of all, it is yes, it is distributed by it's just inherently distributed, right? Everything about it, but also um, it also eliminates like I say that Rama, the applications it helps the most are the ones either dealing with scale, just because scale creates so much complexity, or applications dealing with complex domain models. Because Rama lets you tune your storage to exactly match your domain. Like there would be no reason to ever have a concept of an ORM in Rama because your storage is already exactly what your domain is. You're able to do it exactly as you want it. Same way that like with Clojure, right? You're able to like mold the language to fit your application as opposed to have to map your application to whatever the language allows you to do, like you do it, like have to do like in a language like Java or Python or anything else. Clojure, you can mold the language. Rama lets you mold your infrastructure to match your application. Um, yeah,
I think the scope is probably, like you were saying, we don't have to talk about what we talked about before, but the scope of this is really huge, isn't it? It's not just like you say, it's not just an application. It's the whole data center essentially. It's the
yeah,
application from soup to nuts.
Mm.
right.
Okay, you've got to write the UI still. That
The
is
back
right,
end.
isn't it, Nathan?
It's the back end.
Yeah.
We don't help with the UI
Yeah, I'm
part.
kidding. Yeah, I know that. Yeah, so it's the back end. Um, the front end is, you know, someone else's problem. But the back end is kind of everything, isn't it? Because it's most back ends have either a synchronous perspective, whether it's writing to a database, or they have an asynchronous perspective, where they're writing to a queue. And as an architect, you kind of have to choose a certain set of infrastructure components to match that application's needs. And you're composing these architectural components from either from open source code or from Amazon catalogs or Google catalogs or whatever. But here you're essentially composing it out of data, and then it's just being deployed somewhere. And hey, presto, you've got everything you want.
Correct. Yeah. And actually, and having your back end be tuned to precisely what your application needs helps you with your front end implementation as well. Because your front end's now able to be based on exactly how you want your data represented, as opposed to having to twist it from some other representation.
On that point, then, so what you're saying is you can, because I was listening to someone, I think it was Howard Lewis Shipp talking about REST APIs versus GraphQL. And he was saying, despite the fact that GraphQL is really composable and really nice, and you essentially can specify the queries you want on demand, in fact, a lot of people just take the entire graph and just work it out on the front end. So it kind of works out to be a total mess. So they end up going back in Walmart, I think it was, or wherever he's working, to some simpler perspective because people were holding it very
They're
wrong.
going back to like the standard REST idea of like one endpoint, one entity, that kind of thing.
I think it comes back to maybe it's an education perspective, Nathan. And I think that's the challenge, isn't it? Is how do you convince people, like you say, to unlearn all this stuff, to take that risk, um, and to try something new? It has to be quite the challenge to make people, jump
Yeah.
ship essentially from everything they've learned for the last 50 years.
Yeah. I mean, that's why we announced Rama the way we did. We took the time, we took a lot of time to rebuild the Twitter consumer product from scratch we did Mastodon, which is the same as the Twitter consumer product, right? Just to show that like we're not just presenting a bunch of theoretical ideas. Like we have demonstrated what this thing can do for real on a real application in all of its gory details. A real application, right? Like when you get into like the full feature set of a real application, there's all this messiness in terms of how it works. And like, I mean, you guys know this, right? That
Yeah.
you can't really get across with just like a hello world, right? There's a
Mm.
Mm,
million frameworks out there which look great on their little toy example.
mm, mm,
But then when you actually try to use it on like a real application, you're gonna be like, oh yeah, it actually blows up like completely. There's actually tons of complexity. That's why our Mastodon implementation is so significant because it is really a full app. It's not a demo, like it's a full application. So that's why we
So,
announced it. That's why we announced it the way we did,
mm,
right? And it was effective for our early adopters, right? Like we publish a bunch of case studies now, and that convinced them, oh, this thing could really help us for our solve the issues that we're dealing with our application, whether they're scaling issues or just dealing with complexity. Um, and so, we're going to keep doing stuff like that, keep pumping out material, keep showing examples, and hopefully that helps us get to more and more of the, more and more programmers.
so that that kind of like makes me think of this question. I don't know if the listeners will want to hear this, but I want to hear it. Like, what is the business model? Like, how are you?
I want
Where
you
is this
to.
gonna? Are you gonna like? I don't know. Tell me what the business model. I'll leave it open ended.
Well, the business model is really simple. We just sell licenses, right? So Rama's free to use up to 2 nodes. And then if you want to run at higher scale, then you can buy a license from us. Um, that's
And
pretty
so
much it.
you're expecting to like have people just pick it up, and you're teaching them or how to use it. Um, and they'll notice how much more productive it is, maybe start a startup and need more than 2 nodes as they grow.
Yeah.
And
But we sell
then,
the licenses, it's for more than 2 nodes or for like the more advanced features.
okay.
But yeah, so if you want access to the advanced features or to the higher scale, you buy a license from us. So it's a very simple business model.
Uh-huh.
Yeah.
Uh-huh. Okay.
We have a question from the chat, um, which is this is a good question because yeah, when you talk about unlearning, um, the how to unlearn is even harder than how to learn. So J. Paul says, beyond convincing people to try it, have you come to any insights on how to bring users to a better understanding of or a feel for Rama's model approach?
Sorry, say the question again.
Uh, Beyond convincing people to try it, have you come to any insights on how to bring users to a better understanding of or feel for Rama's model slash approach?
Um, it's challenging because people are so ingrained with the inertia of the industry. Um, so the thing is like you take something like event sourcing, right? Event sourcing is it's a really simple idea, right? It's just you instead of mutating your state, instead of mutating the current state of the world, you record what happened in the log, and then you can build whatever views you want on top of that. Datomic actually is an event source system, although it's an event source system with a fixed data model. Rama is an event source system with flexible data models, as just like one very simplified point of contrast. But the thing about event sourcing is that it has so much baggage associated with it. And one thing that programmers have trouble with is distinguishing between a flawed idea and a flawed implementation.
Mm.
Look at like traditional event
Mm.
sourcing. Yeah, if you build an event source system with Kafka and custom workers and Redis and MongoDB, like for your views, there is going to be a massive amount of complexity there, both conceptual and operational, right? But the complexity has absolutely nothing to do with the idea of event sourcing, but a ton of programmers associate that complexity with event sourcing,
Mhm.
not with implementation. And that's something I'm still trying to learn how to get past, like that kind of inertia, where it actually is just pure irrationality. It is people unable to rationally think about concepts, and then they then make decisions based on completely wrong understandings of things and why things are the way they are.
People
Uh,
never even they don't even look up the term, right? They just have event sourcing. Oh, that means XYZ.
yeah,
And they
exactly.
haven't even looked it up. They haven't defined it.
Right.
Um, yeah.
I
So
think
that's
one thing that's different uh, from my perspective of like in terms of these challenges, the one thing I find is that people say it's the same as your point about Java, Eric. The same people say about data. They say, okay, well, I've got a schema. I can go to the database. I've got a whole bunch of tools. I can explore the data, and I've got tools to like IDEs to explore the code. And as soon as you start to generalize more, the tools become more abstract as well and more tricky, and maybe it's navigating. Like, let's say you have an input of some URLs and you want to find, okay, well, where is that used in my system? And I think people like that tractability. They
The
like that
concreteness.
traceability.
Mm.
All of those things that begin with TR for some reason all of a sudden.
You can always just run
But
PSQL and do a SQL query on your data and just see what you got
Yeah,
in there.
not so much that is true, but also you can kind of you kind of know where it is. Do you know what I mean? You can follow through like a bit of data that's coming from the user. Okay, it lands in this object, it then gets transformed into this thing and goes in the database. And when you go to CQRS or any kind of like asynchronous system, you start to lose those connections. And I don't know if that's something you're thinking about, Nathan, in terms of tracking the flow, like these data flows. It seems like it should be friendly to tools, but I don't see very many great examples of it out there, which maybe this is a fear for people, that they're somehow losing visibility or control of things.
Well, event sourcing gives you fundamentally better visibility in what's happening.
Sure.
Yeah, it's not even comparable to a non-event source system. Event source system, you can clearly explain why things are the way they are because you have a log of everything that happened, fundamentally. And yeah, I mean the tooling is I mean, at the end of the day, like it's all just Clojure, right? Like, yeah, Dataflow is different, but it is Clojure. You use it, you're programming just a Clojure programming. You're not having to deal with like configuration files or like weird stuff that other tools make you have to deal with. I mean, it's just like, I don't know. Yeah, people do have a lot of fears and just like biases, and that's where all the inertia comes from.
I mean, people have the same kind of fear, like like I was talking about, like you're not using a class with methods, you're just throwing stuff in a map. And like
Yeah,
how do you know what you have and how like how are you keeping track
yeah, yeah.
and like you just develop a feel for the stuff that works and the stuff that doesn't work and it's I guess I would think it's similar to this, you develop a feel, oh, I can what is that, pipe hash this thing and get it on a bunch of different machines um and it'll work. um
That's why we announced the way we did, right? Is
mm,
to provide a quantifiable reason to uh jump in and learn this, right? Because
yeah,
it has real quantifiable results in terms of um in this, in the case of our Mastodon thing in terms of productivity.
right.
And then yeah, and there's also a capability aspect to it, right? So like we published a case study like about a month ago, and et cetera, used Rama to completely rebuild this publishing platform that they have that serves like millions of people all throughout
Mm,
Switzerland and Germany. Yeah. And so with Rama, they were able to their old system was um, it was like heavily reliant on caches. So basically to like compute like a page of a digital newspaper, it's like pretty complex actually. There's like a lot of like content and it needs to be like stitched together from all sorts of different places. And so they would recompute it every now and then, like every minute or something, and then they would cache it because the recomputation was very expensive. They had a lot of problems with that approach. Like one problem was the fact that like if an editor wanted to publish something new, it wouldn't actually get published until the recompute window has passed, right?
uh-huh.
The other problem is that they were so reliant on the cache that if any sort of problem happened with the cache, it would sometimes they would have like severe outages because if the system didn't have the cache anymore, it would have to recompute and that would spike load and everything would go crazy. And so Rama let them do it in terms of an event-driven way. Uh,
Right.
Mhm.
and you,
Recompute the cache because I changed something
right, they
in the
don't let
content.
Recompute this tiny bit of data, actually, I guess is the
Yeah,
most
so basically
important.
basically now they assume there's a data flow, right? So new information comes through and then they do like a graph algorithm to determine, okay, that new piece of content, what are all the pages that touches? And now we can just incrementally update those as well as anything else in the system that might need to be incrementally updated. So they're able to now define it in terms of an incremental event-driven workflow as opposed to this more traditional way they did it, where it's read and write to a database layer and do recomputes as necessary, and which is
And is
really
it
a
is it
mess.
1/100th of the code?
Well, the implementations aren't directly comparable. It's a completely different approach they're
Yeah.
doing.
Yeah.
I think their implementation ended up being like 5,000 lines of code or something, so it's still not that much code.
Wow, that's so small. Like you could just learn it. That's 5,000 lines is nothing for like an application like that.
It's a full,
So,
yeah, it's a full, and they actually like if you read the case studies, like really cool what they did. They like built an incremental like little data log engine to support some of the features. So like one of the things on like a newspaper website, a really important thing is like the concept of a list. right? You want to show like on a web page a list of related content so you keep the reader reading, right? So like here's other content you might be interested in.
Hmm.
And the editor or whoever does the page layout wants to say what kind of things should go into that list. And it's way too much work to manually curate the list. So they want to be able to say what should be in that list, but in terms of broad categories, like we want stories from here from a particular location and in this language and on this topic and within this time frame or whatever, right?
Hmm.
So in Etc. They built like a little data log engine for that on top of Rama, where they can like in the UI they specify the constraints that becomes like these little data log records, which then they have a Rama topology which analyzes that and does like a batch looping computation to um, basically whenever new data comes in, it looks at the data log queries that are active and it incrementally updates them by running it. But I thought it was pretty neat. But like they were able to the case study is really cool just because um, they were kind of like no holds barred, right? They were not limited at any point because Rama fundamentally what Rama does is it just gets out of your way. It basically just lets you do arbitrary storage and arbitrary computation wherever you want. And then you compose that however you need to for your particular application. And in their case, it was for doing these event-driven incremental it was actually incremental like graph algorithms to update the content as well as these like incremental data log things to even determine what content should go there.
So like this, what you're saying, like, okay, I totally believe it, right? But one thing that comes to mind is when you're building systems like this, the old way, the
Yeah.
traditional way, the mainstream way, um, usually the real problem is like, okay, it works on one server, but then once you distribute it, it's like there's just bugs all the time. Like it changes the nature of the problem from one of like get the business logic right to now you're bringing in all these distributed systems problems. They have different failure modes. You've got eventual consistency and the acid concerns and what's that theorem? The
Cap, cap,
pack
cap,
theorem,
not
the cap theorem, and so
pack
you're
is
what's that?
no pack is the Pacific Atlantic Coast Conference.
Oh, yeah. Okay, yeah. The cap theorem and these are it's like a different way of thinking now, right? But it seems like if you got the primitives right because they're at like a higher level of generality, they do less, each thing does less, then
Yes.
you can actually compose them because you're solving the problem at a more fundamental level. Like your
Yeah.
P state is like a tiny little database
Yeah.
that is already distributed and already partitioned.
Mhm.
And it's sort of like taking the atom, instead of putting synchronize on every method in Java, you're just like, I'm going to use an atom, which solves the synchronization problem once and for all
Yeah.
by doing very little else. All it does is the synchronization problem, right?
Correct.
Um,
We
is
provide
that is that the right way to think about it?
that's a great analogy, right? Is that first of all the whole concept of like there's a whole thing like once you go distributed, it becomes like much more complex. First of all, you're already building a distributed system. When you have a web server and a database, it's already a distributed system. Okay. And also the complex again, you got to
People
be
are
able
in
to
denial now.
you have to learn to distinguish between the problems with an idea and the problems with an implementation. And a
Hmm.
lot of those things about distributed makes things so much more complex is because of the implementations, not because of fundamentally. Yes, distributed is absolutely more harder. But most of what you associate with the complexity is because of the tooling. Rama provides much simpler primitives that compose, and so you're able to do distributed computation. But like the fact that it's distributed doesn't actually make it more complex.
Hmm.
And in terms of acid, Rama is fully acid. It's like very, very strong acid semantics. Actually provide like very strong acid semantics. Like this one right here. Oh, here's a good one, like bank transfer module. I like looking at this example. This is transferring money between two accounts. And also recording, it's also recording what transactions happened, what were all the outgoing and incoming transactions. And basically the way it's coded is that we just say, just like high level, here we say, how many funds do we currently have? Do we have enough funds to make the transfer between these two accounts? If we do, then we're gonna deduct them from this account, and we're gonna record the transfer in this other P state. There's one P state for outcome transfers, one P state for funds, and then we're gonna switch tasks to the other user ID, where the other user ID is keeping their funds. And then if it was a success because we had enough funds, we're going to add the funds to them, right? So here we're doing a bunch of writes to one machine and doing a bunch of writes to another machine. Which could be very dangerous in distributed context, right? Like what if one succeeds and the other one doesn't? But this thing, microbatching, is a cross-partition transaction in any case. So microbatch code is completely arbitrary code, and the entire result of the code happens as one cross-partition transaction across the whole cluster.
Wow.
Yeah, and you don't have to think about it. You don't have to do anything special. You just write arbitrary code. It's a cross-partition transaction in every single case.
And like it's acid, so it might roll back. It might like not happen. Is that right?
It's going to
Retry or
it'll retry. Yeah, I mean it'll eventually succeed, right? But if there was some sort of infrastructure issue that a machine died, it'll have to retry the computation, but it'll retry in a way as if it never failed. That's why that's what makes microbatching so powerful. And you're able to write the code as just like, yes,
Yeah.
it is. This is Dataflow. This looks foreign. It looks totally different, but we're just
It's
saying, we're
it's
just saying,
sim go ahead, sorry.
yeah, we're just saying, how many funds do we have? Okay, do we have enough funds? And then let's do some writes based on that result. And then let's go to the other node, right? And then do some writes there based on the same result. You see this success variable was actually bound over here, but we're able to use it because it's in the closure. It doesn't matter that we switch nodes in the middle. And then the fact that it's a microbatch topology means you get this very powerful set of guarantees, right? Which is critical for this particular use case.
Yeah,
So
it's similar to like how an atom, if as long as you pass it a pure function, like it's got its own guarantees, right?
correct. Yeah. And
Yeah.
so the computational framework of Rama provides you those guarantees,
Mm.
but the actual code is arbitrary code. Like again, it's arbitrary code wherever you want with arbitrary storage, right? In this case, we have three P states. One for funds, which is a very simple map, user ID to funds, right? This is the same as a key value store. Then we have outgoing transfers and incoming transfers, right? Which are just going to be user ID to transfer ID to then fixed key schema is just a map with a particular set of fields and a different schema for every field. And so here we're saying for this transfer, it was to this user for this amount, and it was it successful or not? Right. And so storage is again molded exactly to what this application needs. And then it's couldn't be more straightforward, the actual code. Do this, do this, do this, do this, we're done.
Nathan, have you heard of like there are tools out there now? I think they're called like durable execution tools. And you think things like restate and stuff like that. And they're basically kind of adding on to existing languages, this concept of retriability and all
Yeah.
this kind of stuff for asynchronous workflows.
Like temporal,
straight-
something like that.
Temporal, yeah, restate. And there's a whole category of these things. And
Yeah,
I
there's
was,
a there, there-
I was
there's a
thinking that this is like you're basically they provide a solution to a problem you don't have.
well, Rama solved that problem's already solved in Rama. You don't have to worry about that.
That's what I mean, So it's kind of like
So those tools,
whatever.
yeah, there's a few things with those tools. First of all, a lot of those, I think it might be all of them are just fundamentally asynchronous, right? It's really for asynchronous workflows, which Rama does not. Rama is actually interactive. You can do like you can build like consumer apps with Rama with I call it interactive event sourcing. That's one of the things that people associate with event sourcing, which is an issue with the implementation,
That
not
it's
the
async, yeah.
So Rama is event sourcing, but does not have to. You can use it asynchronously, but also you can use it synchronously. So that's one issue. The other issue with a lot of those tools, all the ones I've looked at, they do snapshot-based replication, whereas Rama does incremental replication. Snapshot-based replication is so much easier to build, but operationally, it is not good if you want to build an interactive, like any sort of interactive application. What snapshot-based replication means that every now and then you just snapshot all the state and you write it to an external storage, which means if you have a failure, the replica needs to, first of all, load the snapshot, and it needs to replay everything that happened since the snapshot, right? So you could be down for minutes catching up back to the state. Incremental replication means you replicate as you go, such that you have the followers are ready to take over immediately if the leader dies, which is what Rama does. And it was like ridiculously hard to build, but it makes Rama usable in like way more contexts.
Another thought about this, and I mean, I haven't really given it much thought, but maybe you have, is the sort of the Web3 stuff, the kind of crypto stuff. That let's forget the scamming part of things, but this concept of a blockchain where you do distributed transactions, is that something which you're exploring as well? This concept of like making this a blockchain engine?
I have not looked into that at all. Well, I mean, blockchain is supposed to be fun, like not running on any central place, right?
It's a distributed program, basically, usually using some sort of coordinated protocol to make sure that all of the nodes can catch up, essentially.
Right.
But a lot of implementations end up running, in like one data center or on lots of different or in.
Could you build something on top of Rama to be a node of a blockchain?
Yeah, exactly. That's what I'm thinking is
I
probably the
haven't looked at the
case.
details of it, but I don't see any reason why you wouldn't be able to do that. Rama just would give you just a massive amount of flexibility and scalability in terms of defining that how that works. Yeah, I mean, something we've started doing, we'll have more to say about this like later, is building developer tools on top of Rama,
Right.
which are for specific domains. We're going to have more to announce about this later, but the idea there is to essentially use Rama as like the ultimate platform for making developer tools, such that the developer tool you expose is able to leverage what Rama does, but then the API can be what we're working on now is something that's like a super familiar API that anyone could like pick up in like 5 minutes. And then underneath the hood, it's leveraging the flexibility that Rama gives in terms of computation and storage and also deployment. Um, but the blockchain could be, I hadn't thought about that. That could be another instance of that, like a specific tool built on top of Rama for a specific use.
I'm not saying that I mean, blockchain seems to be like it's either hot or cold, and
Yeah,
I think it's a bit. Let's say it's a Marmite type technology, it divides people. But
yeah.
what I
I
was
don't
going
know.
to say to you, just a quick question for you. It's like following on from the knowledge transfer stuff is the most direct way, I guess, that you have knowledge transfer issues is when you bring someone new into the company. So I guess that's the most obvious, like the obvious measure of whether a thing people can grok it or not.
You want to in terms of the
Like
employees.
someone joins Red Planet and they have to go out doing consulting or whatever, or they're making tools using
Well,
Rama, or
the
they're
first.
adding features to Rama. And I guess then they've got to grok the model and grok all
Well,
this
the
kind of
first.
stuff. So
Yeah, the first thing every new Reptile Labs employee does is actually build something with Rama.
right.
Yeah. And so usually spends like about 3 weeks on that. We have like yeah, we have they're not gonna be like full applications like our Mastodon one was, but
No, 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 no.
yeah, but they're still like applications and they do the UI portion as well so that they learn in terms of like using Rama from like what is it like to actually use it from the front end to actually like solve it end to end. We actually built a little UI framework that we use internally for this on top of something called JX browser, which basically lets you do DOM stuff but from the JVM. And so that's how we like
Okay.
interface it so that they don't have to deal with, integrating Clojure or like you could do that, but this just makes it easier for like this sort of like internal employee project. And that's actually been what I find. Like with people learning Rama, it takes like I'd say 1 to 2 weeks for them to like before like the light bulbs really start going off and then they start becoming really productive. And there's still a lot more learning to do after that, in which like asking me questions in like the public Rama channel is like really helpful for that. But like to get like the fundamentals down and like get the flow like internalized, 1 to 2 weeks, which it honestly isn't that long.
No, no, no.
Also, it's not 5 minutes.
Yeah,
It's still
sure.
it still is, you still really have to dedicate the time, but it's not like 2 years. It's not like you have to do a whole college education for that.
Yeah, but I
Um,
also imagine that a lot of people, if they're not familiar with distributed systems, this is like an education in like distributed systems
yeah,
thinking,
Mm,
right?
mm,
yeah, it
mm.
is. Yeah. Well, yeah. Again, they were doing distributed systems. It's they weren't aware of it.
That's
Um,
right. Yeah, they
this,
didn't
this, will make
understand
this will
what's
make you
going on.
more aware of it, right? But all it is just like you have to keep in mind where are you computing right now, right? And once you internalize that, it's very, very powerful because Rama makes it so easy to jump around the cluster. Actually, let me
So,
show
so
you.
what's the hello world of this, Nathan? So, when people like the smallest subset of a working kind of application.
Oh, I mean, that would probably not these examples, but if you look at like the tutorial starts off with literally hello world,
Yeah, sure.
Java, similar. So it's just this is have a depot, and then with stream topology, and then every time it receives an event, it prints the data that it received, right? And so this then launches the module, it appends hello world to it, and so if you run this, it'll print hello world. So that's literally hello world. And I think like the next thing the tutorial does is probably word. Yeah, so this would be like word count, right? So the depot
Okay, yeah,
a bunch of words, and then this is going to hash by the word and then aggregate the word counts.
Hmm.
So it's like extremely basic.
nice.
Yeah. The Clojure version would look. It's basically the Clojure and Java APIs are basically one to one, so the Clojure code would look very similar to this.
Okay.
Yeah.
Yeah, it's pretty functional Java. I was looking at it.
Yeah.
Uh,
It's actually forming the Java API was a little bit challenging because it is the Java API is essentially a thin wrapper around the Clojure API.
yeah.
But then like when you're making a Java API, you want to make it as like I don't know, sympathetic to like the
Ch-
platform that
Chaining and
Mm, mm.
method chaining.
yeah, so like it uses method chaining for doing it. But like there are all sorts of little things like in Java, you would typically use an integer, not a long. And so like
Uh,
some minor
Mm,
differences
mm.
between the Java API and the Clojure APIs, because in the Java API, I make things give you integers instead of longs, whereas the Clojure one would always be a long. All sorts of like little things like that in terms of like mapping them, which I had to work
It's
through.
interesting, like seeing Java written after Clojure, because usually you see Clojure written after Java, and
Yeah.
it's worse. Whereas it feels like Java written after Clojure feels better.
Well, listen, the amount of so Rama has a very good Java API because I put in a ton of effort to basically reduce the number of parens you have to type.
mm.
Like if you just make a
Right.
if you make a Java API, like just a standard Java API, there's so many parens that you have to
I
type.
know Java has so many
It
parentheses.
has more
I
parents than
can't believe.
Clojure.
I'm not even being sarcastic. It is an
Oh,
unbelievable amount of parens. And so like with a Java API, hold on, let me
well, and that's really tough when you're using TextEdit to as your main editor, which
yeah, it makes it
doesn't
even
doesn't have support for that.
But like this right here, this is just for code gen of Java files. So like in the Java API, you have to do stuff with like blocks all over the place. Let me make a new window. So like the Dataflow API is in terms of blocks. And so you write code like this in Java. You say like block dot each ops dot sum a let's say we want to do this, and then we want to say um we want to multiply that by 2. Okay, now in Clojure, this in the Clojure Dataflow API, this would just be this is the same as this, right? So this is how you do it in Java. Now, there's something interesting happening here, which is that this is static method dispatch, and this is instance method dispatch, right? And so if you look at the implementation of block, like basically a normal Java API would be something more like this.
Hmm.
I'd like, oh, look, I have to write new and I have to write
The
two more.
parens.
Yeah.
but now they're all instance dispatch, right? So I had to actually, this is why I have to use so much code gen. I have to do this, the API code gen for both static and instance method dispatch so that you can write
Mm.
this instead of having to write all the additional tokens in parentheses. And it was a goddamn pain in the ass. It's so annoying. Don't have to worry about that. Don't have to do anything like that with the Clojure API. But yeah, Java really, oh God. And then also just dealing with the Java type system. But the other thing I wanted to do in the Java API is be able to use lambdas, right? So here I want to be able to say like, you know, let's say long, let's say we're doing something with a long and a string, right? I want to be able to do a lambda like this, right? And then you can say like let's say this is your function, right? And so this is saying it's going to take the runtime values of A and B and it's going to combine them into a string like this, right? So to get this, to be able to write code like this, you have to go, it's so annoying and how you have to specify the Java API to allow you to even specify a lambda like this, such that you don't have to write it like this. It's a lot easier to make a type like this, and then here you'd have to cast. Yeah.
Casting.
And also dealing, yeah, it's so annoying. This is maybe not the most interesting thing if this is a Clojure podcast, but yeah, this is why I have this file right here, gen Java API files, and I forget what
You're trying to do dynamic typing because the star A and the star B are
correct.
dynamic.
Yeah, yeah. Rama is fundamentally dynamically typed, right? But you want to be able to make a Java lambda, which is statically typed,
Right.
so that you can use, so that you can write Java code that's not full of casting.
Mm.
So that was by far the most annoying part of making the Java API. And you can see like the code to generate the Java files, it's like 700 lines of code. Like it's no joke. Um, yeah, I think. And actually, hold on, look, you can actually see it here. Where did I put it? It was script. Yeah, here it is. So like, yeah, here's block, for example, right? So I'm using, I forget what tool we're using that does this, but it's like a templating library for Clojure. I forget what the name of the tool is. But you can see here how I'm generating the methods along with like the Java doc, right? One for the implementation class, which is going to be the instance methods, and then once for the static. Here's the static methods, right? And I'm iterating through all the methods.
Oh, wow.
Yeah, that was really annoying. But without doing this, the Java API is like so much more verbose because it would be a more standard Java API.
Yeah.
That was annoying.
Do you find any
Wow.
of these JVM type affordances helping you, Nathan? Or is it all basically this sort of generational stuff?
Sorry, what do you mean? What JVM affordable?
Things like these function handlers or some of the sort of lower level parts of things. Or are you always essentially you're sitting on top of Clojure, essentially?
Yeah, this
So what
stuff,
you do is
all this stuff
okay.
compiles to Clojure. Yeah.
Yeah, okay.
And so, yeah, the
So
fact that you
whatever Clojure has, then you're taking advantage of that.
correct, yeah.
Yeah, okay. Got it.
And Rama itself compiles to bytecode directly. It has to
Right.
be
Right.
efficient. But and the way it approaches bytecode generation is a lot of it is similar to how the Clojure compiler works as well. And just like I think our bytecode that we generate for like an if statement is identical to what Clojure does, for example. Actually, I learned a lot from reading the Clojure source in terms of like doing compilers. So Rama does,
Right.
but obviously Rama is a more general paradigm. Call and emit is much more general than call and response, and so the compiler is very different. But some aspects of the implementation are similar to Clojure, and I took direct inspiration from Clojure.
Nice.
Yeah.
Oh, we are 12 minutes over our traditional hour-long runtime. We do have one more question from the chat. Hi, Yo-Yo Broker. Yo-Yo Broker says, I just joined this stream, so ignore my ignorance. Is Rama fundamentally tied to the Red Planet Labs cloud lock-in?
No. So Rama, you run yourself. So you can download it on the website here. Oops. Right. So you just click on download over here, and then you can download it, and then you deploy it to your own wherever you want to deploy it. We have one-click deploys for AWS and Azure, which makes it really easy to set up a Rama cluster. But we never we don't run anything for you. So all your data is yours and all that stuff. So none of that stuff ever goes to us. I think one day
It's
we'll do,
great. So it's got a
yeah, we'll probably offer a managed service at some point, but we don't offer that currently. So currently you just download it and you run it wherever you want to run it.
okay. That was one of my questions, was whether this was something that you could host on AWS. So cool.
Yeah, super easy to deploy, one click deploy.
And you're coming to Europe next week, Nathan.
Yeah, I'll be in London this weekend.
Giving the keynote at Reclosure. I just want to shout out the Reclosure conference. It's
Yeah,
going to
and
be a good one.
Yeah, it looks awesome.
That sounds like fun.
yeah, I'm really looking forward to giving this talk. So this is the most excited I've been to give a talk in a long time. So it's gonna be a good one.
Well,
Thank you so
you'll
much
be
for
there. I'll be there. So I'll see you there. That's for sure.
Mhm.
And I saw Eric at the Heart of Closure because he
In
gave a
Belgium,
keynote
yeah.
there. So Mia, come on, you got to get across to Europe sometime
if
soon.
my boss is watching, if any of my bosses are watching, I would like to go to a closure conference in Europe.
Yeah, yeah, we'd like to have you. Yeah.
So Nathan, thank you so much for giving us this cool deep dive into just really a kind of mind-blowing tool. It was a lot of fun to get a peek into that.
Yeah,
Uh,
glad to join.
yeah.
Yeah, I mean, and thanks for like all the deep work that you've put into this. I mean, how long did you say it took you to, you know,
Well, I've been
you
working on
ba
this. I've been working on this
yeah.
since 2013.
Oh, wow. So wow, that's amazing. Yeah.
It was not easy. It was not easy.
Yeah. Wow. Okay. So
It
thank
was
you so
simple,
much.
not easy.
It ended up
Right.
it produced something simple, and it was incredibly difficult.
Um, so I don't know what else to say except thank
But
you. This was amazing.
we always have one last question,
Oh, we
which
do.
is who do
I'm
you want to
sorry.
see on the show?
Hmm. Um, Actually, you know who would be a really good guest on your show? Would be really interesting. Alan Turing.
Alive, please. Alive, please.
Okay, so,
We'll see.
no,
Yeah,
listen,
we'll see
you
what we can do.
can't do that. But you guys remember the movie that came out like 10 years ago, Imitation Game?
Yeah.
So just have Benedict Cumberbatch come on in character.
Ah,
You know what? Yeah, we'll see. I'll reach out to him.
we'll see.
I'll reach
Yeah.
out to him on the Clojure Slack, and I'll see if he's around. He's always posting. So
Just present it as an opportunity for him to advance his career.
Would you come on a small YouTube channel for an hour in character?
Look, the Rolling Stones play local clubs, you know. Come on.
Like,
Warm up for his next role.
Yeah, well, while y'all are in London, you should try to get him.
get him. Yeah.
that's true. We could do the field
If
work.
he's there, yeah, we'll hit him up. Yeah.
Oh,
Invite him to the conference. All right.
You want to
Cool.
actually answer that question?
Do you have like a non
I'm not gonna let him escape.
yeah.
Oh,
Come
actually,
on, there's got to be someone you like to hear that is, or someone you know that maybe has not appeared very much, or
no. I think Bruce Howman is. I was talking to Bruce recently. He's
Bruce.
been doing some interesting stuff. I think he'd be a good guest.
Hmm.
Awesome. Yeah, I like Bruce.
He's not Alan Turing, but he'll be a good guest.
Close. All right, cool. We'll write that down and get to work on getting Bruce. Thank you so much, Nathan. Thank you everyone for listening, for the questions in the chat. This is the Apropos cast. You can find us on YouTube. Please like and subscribe so that you get notified of when our new videos are coming out. Okay. Thank you so much, and I'll see you later. So, there's
We
a delay. So
Have
I
we
kind of
recording? Or we remain recording?
I
It's all
think
new
we've
tech,
stopped now.
Nathan, you know. It's
We stopped. No, there's always like a unknown delay amount. It's like 15 seconds.